Hello and welcome to another interview at Level 1. I'm here with a very special guest, Jeff McVeigh from Intel. We're here to talk about all things oneAPI. So I saw the oneAPI presentation. I'd say about a third of our audience probably saw the oneAPI presentation, but there's a lot to unpack there. And
Yeah.
I don't know really where to start. So I was hoping that you could give us the 1 or 2 minute elevator pitch for oneAPI and how it's going to make programmers' lives easier. And I'm a computer janitor. I'm helping like the research scientists, and it seemed like it was going to make my life easier. Even though I'm not, I mean, I can program. I have a computer science degree, but I'm not a day job programmer in the kind of things that you're doing. And it still seemed like it was going to make my life easier too. So tell me about
Yeah.
oneAPI.
Sounds great. Thanks for having me here. Let's start from the beginning. So why do we even do this work? Because it has been a large endeavor for us to get here. It's really motivated by a few factors. One is there's just so many different workloads that are out there today that have different computing requirements. Some of them are really amenable to scalar architectures like a CPU. Others are better suited to matrix or vector architectures like a GPU or an accelerator might deliver. And others are better suited for spatial architectures like an FPGA. The problem is, as a developer, you don't want to have to understand the intricacies of each of those architectures, to have different tool chains to develop on them, and to not have code portability. So what we're trying to deliver with oneAPI, and this is our early steps, we know that we're still in the beginning stages here, is to provide a unified programming model across those architectures. And it's not just architectures from Intel, but really an open industry standard, an initiative that others can build upon themselves and implement for their architectures and their products. And the motivation for this is really to enable a scaling of code, workloads, and capabilities across those, and minimizing the rework required from developers so they can bring those capabilities to market more rapidly. Now, as you're saying, Wendell, not everybody is going to code to the oneAPI level. It's more at the lower level libraries and direct programming languages of the stack. But as we know from software architecture, abstractions provide value for each layer that's above it. So somebody that uses a framework like a TensorFlow or PyTorch or a language like Python, even if they're not coding to the direct APIs that oneAPI provides, they get the benefits of those frameworks or languages are optimized using oneAPI. So it's sort of an additive cake of capabilities.
Yeah, I certainly the BLAS, the basic linear algebra system. I mean, in doing some research on that, like just to kind of break it down for the audience even a little bit more, because I mean that's very flowery language, but I need to I'm down here, I'm in the trenches, I've got my waders on. I actually need to get the data from here to there, and just a basic thing like linear algebra. Linear algebra underpins so much of what we do. I mean, it's everything from machine learning, like you were talking about. I mean, that's at the core of everything. But when I was diving into it, some of these research calculations will run for weeks or months. And I was looking at like the BLAS, the basic linear algebra project, which you guys have something better than that. But in just my own experience with BLAS is like, we don't actually know which instructions are the fastest over a long period of time for doing stuff. And so like some of the magic of the BLAST library is that it actually does work on your hardware to figure out which thing is faster, and then you run it with that. And in one project I was working on, it saved us over a week of wall clock time just because nobody had really run it to figure out which kind of linear algebra the processor was doing was faster. It changes from generation to generation. It can change from revision to revision. It can even change depending on the thermal envelope of the server. And for me, the promise of oneAPI is I don't have to think about that anymore. I don't have to dive that deep. It's just I can count on the API running my linear algebra as fast as it possibly can be run on whatever hardware I've got available.
Right, exactly. So let all the details of what's best, what's optimized, let that happen within the library itself. Have a consistent set of interfaces that you're able to code to, and do that across a CPU, a GPU, from Intel, from another vendor. That's really the promise that we're working toward to deliver. Now, as you're pointing out, with each generation of even within a CPU architecture, you're going to always want to have some level of tuning. So we don't want to convey that you're going to write one piece of code and forever for the for future time, you're always going to be the most optimal. You're always going to want to do some analysis. You're always going to want to make sure that you're getting the best you possibly can. And that's why in the oneAPI product that we also offer, we include analysis tools like vTune and Advisor, which allow you to really understand where there might be bottlenecks. What is your roof line of maximum performance, and you can make sure that you're delivering and what you're achieving. There might be some settings, basically, even within oneAPI that you want to tune to ensure that you're getting the best on the hardware you're running on. But you're going to get a large portion of that just sort of out of the box.
Yeah, I think another advantage too that can't be understated is, I mean, I get what you're saying about you're not going to write one piece of code and it's good forever, but at the same time, you don't want to get sort of locked in. And some of the projects I've worked on were kind of locked into like this CUDA ecosystem, and I was looking at the oneAPI examples for porting pre-existing code from CUDA to oneAPI, and it was pretty analogous. I think that oneAPI was only a few lines of code longer, but in the C++ example, it was basically a one-to-one mapping, and if anything, the code was a little more readable in the oneAPI version of that code.
Well, I'm glad you had that feedback. That was one of the challenges is we understand that there's existing code out there. We know that everybody's not going to start from scratch and just do everything from new cloth. So we wanted to make sure that there's an ability for people to be able to take code and bring that to the open language and also the libraries, but also to do that in the most straightforward fashion so that it can be done kind of seamlessly and also readable, like you're saying, so you can have the productivity. So we really want to make sure that there's the balance between productivity and performance, and that's what we're offering with the compatibility tool. And then, the language and library interfaces do have a lot of similarity, even though they're unique. But like you said, BLAS and other things, there's only so many matrix multiplies and interfaces that you define there. So it's pretty straightforward. But to be able to reuse the code is a key value.
Now, in the world that we find ourselves in, at least from some of the other projects and stuff, the other place that I thought that oneAPI might fit pretty good, and you could probably elaborate on this, is the difference between like edge compute and sort of cloud compute. And so I've seen a lot of really innovative applications that use the relatively meager resources of a phone, not just compute, but we're starting to see AI accelerators and augmented reality stuff actually in phones. But then there was some kind of cloud magic thing happening where some of the processing was happening on the phone and some of that data was making its way to the cloud for more processing. And it looked like there's a lot of stuff in oneAPI to make that more seamless for the developer, so they can just say, let's get the calculation done. And there's a lot of helpers there to really figure that out. Can you talk a little bit more about that?
Yeah, absolutely. So you're exactly right, which is it's not just within those different architectures I was talking about in the beginning around CPU, GPUs, and so forth, but then also how those are deployed in an edge device, a consumer device, a PC, for example, an edge server, or back in the data center or cloud. If developers can have the same consistent programming model across those environments, across those segments, then their code can be reusable. I don't need to specialize, well, this part of my organization is only doing mobile application development, or this portion is doing cloud app microservices, or this one's doing a PC application. Be able to utilize a common programming model across architectures and segments allows for just a much more fluid application of both talent and skills so that I can get my code running on those without having to learn each of those architectures independently. So that's part of the vision is how do we not standardize, but how do we make this really uniform and common across those architectures and environments so that we can get the most value, and you're not spending all your time learning about a new architecture, but really understanding your algorithm or your workload so you can make that really shine on the hardware that wherever it's running.
Yeah, I think unless for our members of the audience that have worked on these kind of applications, they've got kind of the direct experience. But for anybody that hasn't worked on these kind of applications, would you say that it's pretty accurate that outside of oneAPI, that sort of the standard way of doing it right now is that let's say I've got a really killer idea for like the next Instagram, but it needs really heavy image processing. It's doing something like what Lambda Labs did with Deep Dream or something crazy like that. So I've got a little bit of that computational horsepower for my app in a phone, But really, the thing that I need is to be able to develop an application on the phone with the vendor's toolchain a lot of the time. And then I have to build my own API, and then I need a cloud service. You know, if I'm going with Amazon, then it's probably Amazon Lambda. If I'm going to roll my own, then maybe I can roll my own and sort of beat them on the cost. Maybe I'm going to use, you know, consumer grade GPUs instead of commercial grade GPUs because, gosh darn it, we're a startup and we just don't have the money for those big, you know, Amazon AWS bills. But each sort of silo, each sort of tier of the, or layer of the onion, ever how you want to think about that, is a completely different tool chain. And a lot of the time, there's not even language overlap there. I mean, if you're talking about Android, you know, Java and Java-based stuff, maybe you get into the machine-specific acceleration at Java, which is like a whole other dimension of insanity if you want hardware acceleration. But the promise of oneAPI is that you can do all of that across architectures, across ecosystems, and not suffer much, if any, of a performance penalty.
Right. That's you described it awesome, the vision of where we need to get. Now, I do want to point out that we are still we're not mission accomplished yet, in the sense that it's not deployed on every phone, it's not deployed in every web service, it's not everywhere. But we've provided the specification for anybody to implement. We're working with over 60 collaborators, companies that are signed on to the vision and are working to bring this to not just Intel architectures, but to other vendor architectures as well. And over time, we'll get there. I just don't want the viewers today to think like, oh man, I can go develop my Android application using oneAPI and I'm all done. There's going to be some stages to get there, but that's where we're all headed.
Well, the website definitely has a lot of step by step. I was also really impressed that it seemed like for the oneAPI there is like a test drive option. You can, like, if you're in the weeds as a developer and you want to play with this, it seems like Intel's opening up a lot of stuff to let you play with it. Yeah.
We have what we call the DevCloud, a little fancy name there, which is really just an environment where we offer up free compute with all the tools, language and libraries already pre-installed, Jupyter notebooks, whatever, sort of tutorials and other ways so you can learn it. But then also to have access to our kind of latest and greatest hardware. So we have Xeon processors, our integrated graphics, our new discrete graphics on the consumer side that we call Iris Xe Max. We also have sort of under select use case right now some of our early data center based GPUs that are not in production yet, but for kind of under NDA access for people if they want to sign up for that. And then our FPGAs, and we'll be rolling out new architectures over time. So that really gives people access to the latest compute capabilities, but all being unified with the oneAPI capabilities on top of them, so you can learn about the language libraries, the functionality of the tools that I mentioned earlier, and to do that all in the latest and greatest hardware for free. So that's what the DevCloud is.
That kind of leads into my next question. So I was watching the oneAPI presentation with Raja Koduri, and what caught my eye was Intel Xe graphics, 4 GPUs basically per card, and it was like 1,000 Dota clients or something, 720p Dota clients, per card, and the server was just humming along and that kind of thing. One of the things that our audience is like super big on and super into that's kind of related to that sort of with Xe graphics maybe is VFIO. And I'm not sure if you're familiar with that, but it's where we can take a Windows virtual machine and pass it a gaming graphics card. And this machine right now that I'm connecting to you on is a VFIO machine. It's Threadripper with 2 GPUs, one for the host and one for gaming VMs. And we're actually doing this inside a Windows VM right now with the video conferencing client. And GVTG, playing with GVTG on the iGPU on the Xeon E3 was like, holy crap, this could replace SRIOV. It's legit that good. And then to see kind of a next generation GVTG, although I don't think Raja Koduri used that terminology, in the presentation was really exciting. And to hear you mention Xe graphics and cloud access, and I mean, I really am hoping that containerization of applications with GPU acceleration is our computing future. But, is that a oneAPI thing? Will it bring us that? Is that in there?
Yeah, that's that is part of the future. There's no doubt, and I love your description of it, and the references that you were describing about the our initial data center products in the GPU space to be able to do sort of Android cloud gaming and some of the video delivery network. That's really where we're we're starting because of the huge demand that's out there with everybody living and working and playing from home. But we know that it's going to continue, and then we'll continue to expand that to other kind of virtualized desktop and other capabilities. oneAPI, again, is somewhat of a key player in that stack, where we call things that are built on it powered by oneAPI. So the Android cloud gaming stack, how we do our video processing and encode decode for that streaming model, it's all built on some of the common libraries that are supported across the CPU, GPU, and other accelerators.
Yeah, so those kinds of technologies would enable consumers to do the kinds of things that I was describing. First, your focus, I guess, is cloud-based, density. But also, I see, in the consumer space, if I've got a single GPU in my machine and I can slice it and dice it up among applications and it works really well, then that's great. But conventional GPU architecture is definitely not designed for context switching.
Yeah. we got a little bit of work to do there still, but over time, the model you're describing is definitely going to be happening.
Well, I'm really excited about the subset of oneAPI, I guess, that builds on GVTG, because that was some really slick stuff. I mean, there's not a lot of GPU horsepower in the iGPU on a Xeon E3, but to be able to run 3 or 4 virtual machines on that iGPU reasonably okay, XE graphics in a server context, that is, and what I saw in the presentation, that is really exciting.
Yeah, well, the GPU in the E3 was definitely a few generations ago. We've increased significantly the integrated graphics support, for example, in our Tiger Lake product, which is XE based architecture, and then we call the server GPU that's being offered through H3C, adding cards that adds these four DG1 silicon together GPUs, and brings that out for those use cases. And then but that's really at our very early state, the very first step in going up the stack in terms of performance and density.
Do you see the software side of that as being sort of in, let's call it user, like speaking specifically about like Linux and how users might get at it, especially in like the context of DG1? Do you see those products as, being things that'll be available to John Q developer, or just J random developer in the Linux kernel, or are they part of sort of an Intel oneAPI overarching special sauce, or is it up to the developer? Maybe you could have it both ways.
Yeah, it's kind of, you can have it both ways. One, the basic building blocks that we use for those stacks are all available within the oneAPI offering, so you can kind of bring them together yourself and develop some of those capabilities, like the oneVPL, which is the video processing library. We also have things around the threading building blocks, oneTBB, and others. Those kind of come together into portions of the Android cloud gaming stack that we offer with SG1. Now, there's some other pieces in there that are kind of proprietary of how we can do the Android game itself on a Xeon platform. So we don't make that just generally available. But some of those other pieces about the streaming, the encoding, eventually the virtualization capabilities, those will all be part of the kind of the toolbox that people can bring together themselves.
Do you see oneAPI as something that will dovetail really nicely with like cloud service offerings that Intel has? Or will you be able to achieve pretty much all of oneAPI in a fully, let's say, on-premise edge compute device?
Answer sort of again both. We want to be able to support both local, on-premise, your own data center, cloud infrastructure as well. We're making these, and this is somewhat more of the distribution delivery of it, but all of them are kind of available today through your common repositories and other venues. We also have a container portal, but we'll also be making them available through the CSP marketplaces. So we're trying to make sure that they're tied together, but not fully dependent upon and only available through the clouds.
Well, I mean, it's certainly, everything that we've described, I mean, if it didn't have the backing of Intel, I would, I think critics could describe it as, sort of a pie in the sky approach, but, it has the 800-pound gorilla-ness of Intel behind it. And it does seem like there's a need for this because, developers are having to deal with, a half a dozen different stacks to be able to push out an application like this.
Yeah.
So, is there anything else that you would say about like oneAPI and like plans for the future and integration?
Well, I'll just comment one on your observation there. Almost unilaterally, whenever we talk about the vision and what we're trying to accomplish, people say that would be amazing, and when can I have it? And then the second question is, how real is it? And when are all the other vendors going to be on board with it? So that's been a bit of our process we've gone through over the past year of getting out these successive betas to kind of build out the capabilities, the stability, performance. And now that we're at a maturity level of kind of a full production, this is really when we're going to hit the gas on getting this rolled out, working with other vendors that we have been working in the kind of the background, but to get that more broadly. And Intel's absolutely fully committed to this and is going to be pushing on this hard. I've actually forgotten your initial question. I was spilling so much.
No, it's because, I'm not, oneAPI is so new and it's so ambitious. I'm not entirely sure what to ask, but, there are aspects of this that seem rooted in real solutions with real customers. I think that there are a lot of detractors that will say, well, Intel's kind of working in a vacuum. They're just sort of doing what they anticipate. But with the cloud gaming stuff and some of the other stuff that you've kind of alluded to, these are based on real world customer problems. I mean, if you could talk about some of that or any of that has led to some of this innovation, that would probably be interesting.
Absolutely. Yeah. So that's great. As we always want to do, we want to be listening and working with our customers to understand what their pain points are. And the pain points that we've heard is, there's existing proprietary solutions today, and I don't want to be locked into that. And I want to be able to have an opportunity to have code and choose the vendor of my choice. And that's really what oneAPI provides, is this freedom of choice between how do I program and how do I get full productivity and performance. And the use cases around delivering Android cloud gaming is just one example. Tencent is one of our partners that launched that service as part of the server GPU launch, and they're finding great success with being able to deliver high density of workloads through that. On the complete other extreme, we have your sort of classical high performance computing engagements, where people are developing their tsunami simulations and these elaborate particle physics collision simulations, all built on the capabilities of our math kernel library, the data parallel C++ language, and others. So it's really trying to understand. It's a broad set of customer bases and uses we're trying to marry together, but boil those down to what are the constitute libraries, functions required to do that in a language that allows people to leverage those libraries, but then also extend that with their own needs. So those are just sort of some customer examples that we have today.
So like to kind of relate that back to the BLAS example, sort of down in the weeds, not the lofty, language of the ivory tower of, Intel and solving problems. It's a lot of the time the researcher doesn't know what's actually optimized, and if the platform itself can help the researcher do some of that work to show you some numbers or insight, or just let you see inside the black box, then the tools that oneAPI gives you will help you sort of solve those problems easily, as opposed to what it is now, which is lots of make files and carefully stepping around the compiler and maybe an automake script that's not let's say bug free. And it's just not a pleasant experience if you're a researcher, because you get distracted working on the machinery and you can't do your research science. You can't do your tsunami simulation. You can't do, you can't really get at the meat and potatoes of whatever it is you need to work on, which definitely is a problem.
Yeah, I mean, most programmers prefer to be able to think about what is the algorithm, what workload, what problem am I solving and delivering, as opposed to all the infrastructure pieces that you're talking about, the build system, the tool chain required for this architecture. I don't think anybody's like super excited to have to do porting between different architectures. Give me one that I can code to a common one and use that across solutions, across hardware.
Oh, the solution to the problem that we were having for the last 2 months is I should have been using the low latency version of the Linux kernel as opposed to the default version of the Linux kernel, and it's like, oh well, of course you should have known that as a research person with a PhD
in particle physics. Yeah, exactly. Yeah, let the people let developers innovate on their concept, their idea, as opposed to the nuts and bolts of how do you get things done.
Well, so you kind of touched on this a little bit, but I want to revisit it. And some of it is Intel special sauce, but a lot of it is also open source. And so tell me about how open source dovetails with oneAPI. And how, I mean, a lot of programmers working on this are on the Intel payroll. Don't get me wrong, but there's a lot of open source. Like as I was researching this, there's a lot of open source organizations and companies that historically have worked in open source that are also working with Intel on this.
Yeah. Yeah, we've taken an approach, and I think this is common in the industry right now, which is for the most part, so actually not for the most part, for all of the oneAPI, the interfaces themselves, the specification, the language, they're all open. Anybody can implement any architecture. We welcome and encourage and support you to do that. We also, for most of the libraries, we provide implementations in open source as well. Full implementations, fully optimized, the one TBB, one VPL, one DAO, the data analytics library. I'm trying to remember if there's any,
linear algebra.
Most of those ones, yeah, the one DNN one, the one communication collectives, all those are fully open source. We have a few, our one MKL, the math kernel library, where we have some really, like you said, secret sauce implementations of some of the matrix and capabilities that we've implemented, and just that fully isn't fully open sourced. But anybody can implement the same API and do their own version of that. But the rationale for doing that goes back to this choice and allowing people to have flexibility. We know if it's only proprietary offerings, then people will feel like, well, I'm just going to get sucked into another proprietary island, and then I'm stuck there. This really gives people that confidence that they won't be locked in and have the ability to implement on whatever architecture suits their needs.
Even with the API, there's no danger of like the Oracle type API interface situation where it's like, oh, this is open, but it's not.
No, look, I'm not a lawyer, but read the. We worked with all of our lawyers to make sure that we're delivering, the specification, the APIs that others can implement, and that's exactly what the route we've taken here.
Is there a particular example or use case or any kind of a story that you can share of a win where you were working with something on the CPU and then it moved to the GPU and then it moved to the FPGA, or there was some story of something that made its way around things and you discovered something that you didn't expect?
Maybe I'll give you an example of we already referenced this code, but this tsunami simulation called Easy Wave, which was originally a CUDA implementation that utilizing the compatibility tool moved over about 85 to 90% of the code sort of automatically. The last 10 to 15% required some kind of manual intervention, but with a well-coded, well-commented code. And then that code was running on a CPU, a GPU, an FPGA, and back on the NVIDIA GPU with about 85% of the performance of the native CUDA code. So that was an example where it really shows the ability to bring that full breadth of architectures to bear with a common language and programming model, and really, some level of performance degradation relative to the initial fully optimized CUDA implementation, but well within reason from my perspective for being able to have that flexibility across those architectures as well. So that was a key kind of existence proof of how we can do that, and we're seeing that more with other workloads too.
Yeah, a lot of people don't realize that when you're working with something like PyTorch, for example, or Python, the performance penalties are quite a bit more severe when you're working in native Python. But then some clever person has actually written the interface in something else that's actually efficient, and then provided the appropriate interface for Python, PyTorch in this case, to be able to use whatever it is at near native speed. So only a 15% performance loss for native, let's call it code, that's pretty darn good.
Oh yeah, when you have examples of just sort of what I call naive Python code, you're orders of magnitude off in performance, not just a few percentage. Yeah.
Well, unless I'm mistaken, I don't think Python still has proper multi-threading. So I mean,
That's a challenge. Yeah.
But it's easy for research scientists to pick up and be productive in Python, so it has
Oh,
advantages.
it's a great learning. It's a great language. It's a great language. But with each step, you want to make sure that after you get past the initial learning and productivity, that you're also able to get performance. As you said, you don't want to spend weeks on something when you find out later this could have been solved in an hour if I was just using the right flavor of it.
Now, kind of switching tracks a little bit, it seemed like as I was looking through like the islands of functionality, for lack of a better way to describe it, in the oneAPI hierarchy, because there's a lot of stuff there. It seemed like that there was a subset of oneAPI stuff that is geared toward creating microservices. And that made me think, it is like, is there entrepreneurial options for somebody to create oneAPI microservices around their own special sauce? Because it seems like it's built to do that. Or is Intel working on something that is basically something like Amazon's Lambda, but is something that Intel actually offers, or is partnering with somebody to offer something like that?
No, I think that's a good opportunity for people, in the sense that we're not gonna deliver the full stack. I mean, we want to focus on some key areas that are typically closer to the hardware, because that's where we have a lot of our knowledge about the hardware. But then to allow for other portions of the software stack, the middleware framework, the applications, the services on top of them, for that to be a vibrant ecosystem. And we're not looking to kind of take over kind of those roles from other people. We do want to make them able to develop those easily. And we'll partner with them on understanding the requirements and bringing those to market. But we're not, planning to kind of do everything up the stack that you'd ever need, and there's only a one stop you ever need to go to. So we'll continue to work with them.
It's kind of a kind of a roundabout concept, and I'm probably a little bit in left field with it, but it's just watching Amazon develop over the years. In the beginning there was PostgreSQL, and then Amazon sort of embraced PostgreSQL, and then they extended PostgreSQL, and now it's not something really recognizable as PostgreSQL. Same thing with Redis. And Amazon embraced a lot of the open source stuff, extended it, and none of that really made its way back to the community. But the juxtaposition of that is, it seems like Intel's kind of doing the opposite, where they're open sourcing a lot of things. A few of those things that you described were not historically open source, but have only recently become, like Intel's made the decision to open source some of the componentry. Not all of it, but some of it. And in that way, if Intel is not positioning itself as a service provider for these APIs to have, some versions of this behind closed doors, the way that there's a closed door version of Redis now, then that does create a lot of entrepreneurial opportunity for people that might embrace the open source aspect of it and build out a community. So even before we get to applications and all this other stuff, it seems like, is that something that Intel is thinking about? Is that something that's anticipated? Are your customers, your early adopters, already doing this? I mean, Tencent's probably got some special sauce going with this.
Exactly. Yeah, everybody's building on layers of it. We highly value the ecosystem. The x86 ecosystem has been around obviously for decades now. We want to continue to encourage and make that vibrant. Now that ecosystem will continue to sort of up level in its layers of the abstraction. Before, it was a big thing to go from assembly code to C, but now it's microservices and so forth. So each generation, we're kind of extending up how far we go in the stack. But we will continue to work with and want to be making those entrepreneurs and other companies successful as they build out their own capabilities.
Well, in that vein, knowing that some of the stuff you can take for a test drive right now, and looking at some of the stuff that's available, is there anything that you would suggest for like a computer science student or a PhD research scientist who knows enough to be dangerous and they want to kind of get started and play with it? Is there a sandbox implementation that they could play with and do something productive with? Like where would you suggest they start?
Yeah, I would start going to the DevCloud. So it's on the Intel oneAPI website, easy access. You just give us kind of your contact information. Within a minute, you're up with a Jupyter notebook running, and within that, there's sandboxes with tutorials of learning the language, learning how to use the deep neural network library, deployment of PyTorch and TensorFlow utilizing oneAPI libraries. So that's really the best way that I would recommend to get people running on the hardware and the latest software as quickly as possible.
Do you have any sample applications or anything that they could get up and like, AI deep learning chess or AI deep learning.
Yeah, there's definitely, we have samples up there as well. They range from some simple sorting applications that you'd find in a CS 101 kind of class to to Mandelbrot's to more complicated deployments of like I said the actual frameworks and so forth utilizing the libraries. So I think there's a good progression of those tutorials and samples that are available there.
Well, I'm definitely going to encourage everybody to go check that out and see if there's anything they can get into, because some form of this, I have no doubt, is the future of these kinds of interfaces. Because as a developer, like, I can see on the developer side of things that I've got to conserve brain power, and I spend a lot of brain power keeping operations going. I just want to program, and so
exactly
the more you can abstract it with as little penalty as possible, the better it's going to be overall. So learning to use this and learning how it's all put together is really pretty fantastic. And
we would love feedback, from everybody. We, like I said a few times already, we know this is some early stages. I'm not trying to scare anybody away, but I also want to just set expectations that this is a journey for us to build out these capabilities, and we want to learn: are the samples and capabilities that we offer, are they helpful? Are they complete enough? Should we be adding more? We're very receptive to having that engagement and working with developers on that.
Yeah, I mean, there are opportunities here even beyond just developer friendliness. Things like application security. I mean, it would probably be trivial to win a ton of government contracts for assured secure computing facilities where you've got encrypted memory and encrypted VMs, and things like DG1 where you've got acceleration, but there's not really a side channel for one application to share data with another application, and they're all running in different security contexts. Like, that's a thing that doesn't really exist today, should totally exist, and it seems like oneAPI, that's just going to fall out of the functionality in oneAPI because it's so ambitious. So
yeah, it is. As you said earlier, it is ambitious. We have a large Intel investment on this now. We will continue to be doing that, but all those opportunities, those are ripe for the taking. So we're looking forward to all your ideas being implemented, Wendell. Keep them coming.
Exciting times ahead. Well,
yeah,
I've taken enough of your time. Is there anything else that we didn't get to talk about oneAPI that's especially interesting or neat or something people should check out?
I think the only other one I just put a plug in here because some people might be familiar with some of the Intel's prior tools, our Parallel Studio and System Studio. Those have all sort of been kind of transitioned, replaced by the oneAPI product now. All those capabilities are now offered in what we call the oneAPI toolkits, and there's a version of all those that are free for any use. Our highest end compiler technology to our analysis tools and libraries. People can get those for free and use them however they want. And then we also have kind of commercial support versions. If a company or an individual wants to have a higher level of support, those are available too. So that's just sort of my final commercial plug, I guess, for for the product, just to kind of level set people on that. This is another big change here. In addition to going more open source, also making all those capabilities available for free for people to get sort of unfettered access to the latest and greatest technology.
Well, I'll definitely add links for all that below. You just missed Devember. There's a yearly thing that we have where, we have like development projects and contests and stuff in December. And this year we started a little earlier because of the whole global situation. It's like, you're home anyway. You're not doing anything. Let's just start it a little early. And so I think my goal is to revisit this, come probably October, and see where we are with oneAPI. Maybe get my hands on DG1 or something like that and see where we are, because some really interesting, you might be surprised, some really interesting DG1 projects may come out of that. I don't know. We'll see. We'd love to see that and work with you guys to make that happen. So let us know how we can help. Awesome. Well, thank you very much for taking time to meet with me and to share the wisdom about oneAPI. It's definitely something that I'm going to follow with interest. So
great. Thank you so much.
It lives up to expectations. Thank you again.
Absolutely. Take care.